Good morning, Dr. Paul Swan. Thank you for joining us today for our webinar, Reasoning with Rods. How are you today?
I'm well, thanks, Heather, and beautiful weather we've got here where we are anyway.
Well, we're a little bit colder over this side of the world. Anyway, I think we're about 4 degrees today, so I'm very jealous. However, I'm looking forward to reasoning with rods. Now, I know that rods are used for, you've got basic counting, sequencing, patterning, but also our algebra. Is that correct? Reasoning with rods?
That's correct, and maybe a little bit of fraction work as well.
Fantastic. Well, we look forward to hearing all about it. I'm not going to take any more of your time. Welcome, Dr. Paul Swan.
Thanks, Heather. Now, just to sort of put a bit of perspective into what we're going to talk about today, essentially we're talking about a tool or a piece of equipment that is based on length. So what we'll do is I'll get you to have a look at some examples of rods, and then you get a bit of an idea of how they work and the principle on which they're based. So I'll switch over to the other camera, and you see I've got some examples of rods just sitting here. Now, a couple of things. I just have a jumbo set here that's a bit easier to see, but there's some one set of rods. Now, they come in different forms. The ones here you probably won't be able to see, but they have, you might just be able to see little marks etched into them to show how the 10 of those small white ones will fit along this rod here. Or in this case here, you might notice that there's some little pieces etched into them and so forth. So this is one set, different types of sets and color schemes. Now, there are some other sets and color schemes, so I should mention those as well. So here's a couple of different types of ones. Once again, they've got that little etching that's sitting inside there, you'll notice there. So that you can get rods in different color schemes and so forth. So it makes sense to stick to the one set of color scheme and talk about it that way. For today, because I've got these larger ones, we'll use this set of rods here just to illustrate and demonstrate a few key things today. You can also get some rods in what they call weight-related rods. So in other words, the small rod weighs 1 gram, the next one weighs 2 grams, 3 grams, and so forth. So let's just have a look at how they're related in length and how we use length to learn some things in mathematics in particular. So I'll head you back down to the camera here and so forth. And I'll just use the large jumbo rods to illustrate what it is. You may not be able to see this one here, but you'll notice that essentially these are all related in terms of length. So you might notice here that 2 of these white rods fit on top of that red one, or 3 of these fit on the green one. As we get to here, remember I showed you the ones with little marks on it, you'll get 10 of those fit along that one. And so quite often people refer to the rods by numbers. So for example, that black one, they sometimes refer as the 7 rod because 7 of those fit on it. Now, bear in mind, if you start to do that, you can restrict some of the things you might do a little bit later. But we're just going to play with some pretty simple ideas today and then build and build and build and so forth. So essentially, as long as we understand that everything we do today is about length, and we're building this idea of length, we'll start to see how this tool works. So I'll take you back onto the screen and let's look at a couple of basic ideas that sit here. And we're going to use, to begin with, a yellow rod. So I've got this yellow rod here, and sitting on side here, we might talk about things that make up or give us the total there. So for example, I've got this rod here. Now remembering this rod here is 4 of those white rods long. And so that we can see that when we put those together, that we've got this rod is 5 units long. This one's 4 units long, 4 and 1 is 5. So what we've done is built a bond or a basic addition fact. Now we could change that a little bit. If we look at this one here, we still got that same bond of 5. But in this case here, I've got this one. If you look at it, it's 3 white rods long. So it's 3 and 2 rods long. So it's 3 and 2 is 5. And so we build up, first of all, some basic addition facts. Now, you can see it's not a big stretch to then go to something a bit longer. So this rod is 1 rod longer than this one. Okay, so you can see that's 1 more. Just to see, have a bit of a look, you can see that that's, and you could look at what fits in that spot there and so forth. So we could do the facts that go to, say, 6. We could do this rod here. This orange rod happens to be 10 units long. And so we could look at the facts that go to 10 by laying other rods on it. So that would be one idea. Let's build on that idea just a little bit. And so what I want to talk to you about is an understanding in mathematics. And the understanding is really about the idea of, they call it the commutative property of addition. Fancy name. What it means is we can turn things around. So let me have a look and you'll see what I mean when we head down to our screen down here and have a look at the rods and how I've set them up. So if you just head down and have a look there, you'll see that we have the same one here. So that was, remember that's 5 because it's 5 long here. If that's 1, then there's 5 of them fitting there. And you can see 3 and 2 is 5. Well, watch what I'm going to do. I'm literally going to turn that around. Sometimes I refer to these things as the turnaround facts, and you can say that 2 and 3 is 5. Let me illustrate that. I'll put another set of rods on there, and you start to see how you get that building or that understanding that happens. So the turnaround facts, or the fact that 3 and 2 and 2 and 5 will give, sorry, 2 and 3 will give you 5. They just help you understand that idea. So embedded inside some of these manipulative materials are just some of those sort of key ideas that we have in mathematics. So in order to halve the number of facts we need to learn, if we know that idea that you can turn around the fact in addition, and likewise in multiplication something similar, then you can reduce the number of facts to be learned. So that's just one little aspect. Let's look at a couple of different ideas and see how they build and build and build, remembering that everything we do with rods is about length. And so we're always talking about the length of the rods that happen here. So what I'm going to do is put 2 rods together, in this case here, and I put them end on end. So I'm going to grab this rod here and this rod here, and you'll start to see how they go together. And so the expression I might refer to that as being a train. In other words, it's 2 rods joined end on end, and we can see that I could get 15 of these white ones would fit along the top. So that's got a length of 15. Now let's talk about something like the idea of division, or the idea of things having factors or multiples. Some of those words are all going to link together. So what I now have is a rod that's 15 long, in this 15 units long. Now, if we use the small rods here, so the smaller version, so remember I've been using the jumbo ones, the smaller versions, that would be 10 centimeters long in this case here, and each of the rods is 1 centimeter different in length. But in this case here, we're just going to have this length of 15. And all I'm going to do, if you watch here, I'm going to lay some rods along here. And if you just watch on the screen there, so what I'm doing here is now looking at, you can see that I've got 3 rods of length 5. And so I can see that 3 5s are giving me the 15. But I can also do something different. Look at this. I'm putting 3 and another 3 and another 3 and another 3, and there's another one. And so now we can see that 3 5s or 5 3s both give me a length, in this case here, of 15. So that's that sort of link between 5 3s and 3 5s. They will give me that same length. Now, it's not strictly true to say that 3 5s and 5 3s are exactly the same, because say a doctor told you to take 5 tablets 3 times a day is different to 5 tablets 3 times a day. But in this setting here, the 3 lengths of 5 will give me the same as 5 lengths of 3. So we're getting that picture there. And so that's a really neat thing for when we're learning things like multiplication tables, the idea of skip counting, some of those ideas of multiples and factors and so forth that build in this sort of idea. And there's some key things that would happen here. So now let's just expand a little bit on what we're talking about and build some other little ideas, once again, all based on length. So I'll take you back to the rods here, and I'll give you an example of what we might look at. Now I'm going to use the smaller rods for this one and make it a little bit easier. And I'll move these out of the way so we've got a bit of space. And you might have noticed that this session, I started with a thing called a staircase. Now, a staircase is literally where I've just laid the rods in order. It's a bit hard to see this little white one here, but you can see that I call this a one-step staircase. So each stair goes up by 1 more. And so I can see there, if I wanted to, if the white has a value of 1, then the red one's 2, this one's 3, 4, 5, 6, and they'll go all the way up to 10. Now, if we look at that staircase idea, we don't have to just always look at the idea of length. In this case here, let's think about the area. In other words, what's being covered in that staircase. So if you think about it, if I use, once again, just the white rods here, and I was going to cover this, you can see, well, it takes 1 rod to cover that one, 2 rods to cover the 2, 3 rods to cover the 3, and so forth. How many rods would it take in total to cover that staircase? Well, that's actually quite a complex question if you think about it. And what I'm really doing is adding 1 and 2 and 3 and 4 all the way up to 10. Now, I could literally cover all the pieces and count, but that'd be time consuming and fairly inefficient. So I'd just like to share a couple of ideas and how just by using a manipulative like say a rod or length-based material, you can start to get some reasoning or some thinking happening. So watch what I'm going to do as one sort of reasoning happens here. So all I'm going to do is move these around. And if you see here, I'm just moving this rod here and I'm making, can you see there? So now this rod, the orange one is 10 long. I've got the blue one and that white one makes it 10 long. Watch what I'm doing now. I put the red one and the brown one together. I put the black and the green. I've put those ones together and we start to see if we use a bit of reasoning. So remember this session is called reasoning with rods. So the rods are there to help us to think, to reason. Now, just a reminder, in order to reason, we need a mathematical vocabulary. And then what we want to do is mold some ideas around in our head. So remember the key idea today is that these are length-based materials. So now let's go and have a look and see how length can help us a little bit with what we're about to do. So you might have remembered we started with the staircase. Now, remember what we've got to here. So there was my original staircase, just a reminder. So this is what it looked like. We just made a staircase up. There it is sitting there. And then we talked about the area of that staircase and we noticed that we've moved it or manipulated it. Now, if we think about it, what's the area? Well, that's 10 long, 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 and that's 5 long. So I think the area is 55. So that's one way of tackling that problem or reasoning about that problem. But I'd just like to take you to another way of reasoning or thinking. And once again, it's as though when you're using these manipulative materials, the thinking is down there on the table. So when you're observing children do this sort of work, when you see them moving it around, you're getting an insight into what's going on in their head. So if you head back down to the visualizer, you'll just see that I'm going to reform the staircase there. So now can you see we had our original staircase and we've got 2 of them now. So here's another way of reasoning or thinking about this problem. So one way would be to turn this around. So now I'm going to take all these pieces and I'm just going to put them around this way and start to see that we'll put 2 staircases together. And we're now building a bit of a mat in this case. In fact, these are all things, if you look here, they're all going to add to 11. And all I'm doing is putting these pieces here and you'll start to see there's that idea of that commutative property coming about. You'll start to see it form. And it's very interesting when you start to, if you put them all close together. Now, you notice I'm using one of the rods just to get it focused. In fact, I can leave it like that, or I can turn it around. And you can start to see that these pieces are all 11 long. And I've got, if you think about it, there are 10 rows, all 11 long. So the total area of that is 110 square units, but a staircase is only half of that. So in fact, I might just move this across and you'll start to see what happens there. So you can see there that 110, then I halve it and I've got 55. So the area is 55. So there are 2 separate ways that we have reasoned with rods, this length-based idea. The colors are just helping us to refer to the pieces. It's almost immaterial, it's about the length. And then what we're talking about now is how to think it through. So just a reminder, so far what we've done is we've looked at the idea of addition, because we put 2 rods end on end, we turn them around, so there's a property there. We also looked at the idea of multiples and how they fit along. And now we've done a little bit of problem solving and reasoning that would sit in here as well. Now, we want to just extend a little bit further, because I'd hate everyone to think that rods are just about some basic mathematical ideas. What I'd like to do is take us into some fraction work so that you can start to see how the same idea can then be taken much further in this sense. Now, to do fractions, I'm going to head back to my large rods because they'll be a bit easier to see in this case here. So I want to take an example. And so I'm going to take this one. I'm going to work with the brown rod. Now, the brown rod is 8 of those along, but I'm not going to refer to it as 8. Remember earlier I said be very careful about how you refer to the rods, because you can restrict your thinking. We know this is 8 units long, which is pretty neat, but now we're going to play with this idea a little bit. You'll start to see what's going on here when I put these ones here. And now I'm going to talk about this rod, the brown one, as being a length of 1, or having that idea of 1. Okay, so that represents what the one, the whole is, the unit in this particular case. Now, if you have a look back down on the screen, you'll notice that I've now put two pieces there. So these sort of pink or purple rods, depending on how the colors work a little bit here. So it takes two of them to make one of them. And you notice here, so that's covering 1/2. You can have it this way, it doesn't really matter, or how we have it here. Okay, so that's the half. Now remember, we're talking about length, half the length of that rod. So if I put two halves, I now get a whole. Now let's extend that thinking a little bit, and I'll move those out for the moment. Just put them over here, and we can start to see in this case here that I'm going to put 4 pieces along the length. And so we start introducing, if this represents 1, and then I've got 4 equal pieces along here, we might refer to them as fourths or quarters. And so this is now broken up into fourths or quarters. And you can start to see this is 1/4 the length of the whole or the unit. And it takes 4 quarters or 4 fourths will give me the equivalent of 1. Let's just take it one step further. So now we're going to go with the white rods, and I just put them there, and you'll see that there'll be 8 of them that fit along here. Now we have 8 equal pieces, and they're fitting along here. So we've now got the idea that each of those pieces, if this is worth 1, then each of those pieces would be 1/8 of the length. You start to see, if we put it there, you can see that we 8 of them fit there, and each of those an 1/8. Now let's just bring these rods back for a moment. And now let's talk about how with length, so this is a length-based model. We can use other models. For example, we could use pattern blocks, but that would be an area-based model. So we've been talking about length. Now let's just pull these aside a little bit, and let's talk about equivalent fractions. So happy that's 1/2. If I pull this across here, we can see here that in this case here, these were fourths, and I've got 2 of them. So 2 fourths is the same length or equivalent to 1/2. And now if we just pull those away, they were eighths, remember? So I have 1, 2, 3, 4, 4/8 is the same length as 2/4 is the same length as 1/2. Excuse me. So you start to get an idea of why length was so important. We're building that notion there of some fraction work. And then what we did there when we looked at them being the same length is that we had the idea of them being equivalent. Okay, equivalent fractions that would be there. So I'm just going to grab my glass of water here and just have a glass. But just thinking here, we're talking mostly about this length idea, and we keep emphasizing the language as we talk. So let's recap a little. We've talked about the idea of length. We've talked about addition. We've talked about turning things around. We've talked about factors. We've talked about multiples. We've talked about area. And we've also now talked about fractions. Now we can do a lot more with fractions, and we can play with that idea, but I just want to give a bit of a focus for him. Now, a couple of other things that we can do, because we're all about length. So I'm going to take another piece of equipment. You may see these in a storeroom in places there and so forth. And you notice it's like a grooved ruler. And so I just want to talk about what we can do with this idea and a pretty simple game that we might play and so on. So this one just fits your normal size rods, and you'll notice that they fit, if you have a look here, they fit inside this piece. You see how they'll slide along? So we can have any sort of piece that fits in here. And you'll see, for example, that this light green piece, if we push it down this end, is 3 centimeters long because it matches into the 3 that's happening there. Now, what I'd like to talk about is a very simple game, and it's very useful for just developing a couple of these. So imagine you've got this ruler and someone else has got another one, and I roll the dice. And when I roll the dice, say something like a 6 comes up. And what I would do is I'd place the rod that's 6 in length along there, and you can see that we've moved along 6 centimeters in this case. Now, imagine I roll the dice again and I move along and I rolled a 4 and I slide the 4 in there, and you can start to see now I've got 6 and 4 and I've got all the way to 10. Now I play a little game here, and the idea is it's called make a meter. Now it doesn't have to be a meter, it could be 50 centimeters or whatever it is, but essentially what you do is you roll the dice and you pick up the piece that relates to the length. So for example, if I rolled a 3, I bring up the piece that's 3 centimeters long, which happens to be the light green one. If I rolled a 5, then I pick up this yellow piece because that's 5 centimeters long. Now, you can play 2 players, 3 players, 4 players, and you don't have to use a ruler with a groove in. Any meter length ruler will do exactly the same sort of thing, and they play along the meter ruler. Now, if you've got 2 players, one can be one side of the meter rule and the other on the other side, so you're playing either side. But basically, you're rolling the dice, doing some addition. Now, if you think about it, if you watch back down here, look what happened when I did that, when I rolled the dice twice. So can you go back and have a look here? Now, once again, I said, we could have one player that's just sitting this side of the ruler, and we could have another player that's sitting on the other side. So let me give you an example. And I'll show you what's happened in this particular case here. So we've rolled this player here, the player on the top of the ruler, rolled a 6, then they rolled a 4, and now we're at 10. In this case here, this player rolled a 7, and then they rolled a 3, and now we're at 10. So you're probably recognizing, once again, we're doing these bonds or facts that add to 10, just from a really simple game, which is really about the idea of length. So I call that the make a meter game. You can see here that this one only goes to 25 centimeters. You can make it 50, you can make whatever it might be, but very simple idea, and lots of schools have rods left over. So I thought we'd just finish up with an idea of pattern. Now, at the beginning of the seminar, this webinar, we talked about the idea that we can do a lot of number work. We've also just done some area before, and we did the area of the staircase. We've just done the length idea, so measurement, but I'd like to do a little bit of algebra. And so give you an idea, algebra is really about patterns. So I'm just going to build a little pattern here, and you'll start to see as it develops how the pattern develops. I'm using my large rods again because it'll be a little bit easier to see. And you start to see that what I'm doing is encasing this rod here. Okay, so you might see I've encased the rod here, and then I've got all these ones around here. Now let's just talk area only at the moment. So the area of that white rod, just that piece we can see, the flat surface, that area we would call 1 unit. Right now, if we follow that logic through a bit further, the red pieces, take 2 of them, so that's 2 units, that's 2 units, that's 2 units, and that's 2, so that's another 8 units. The total area is 9 units. So we started with 1, and now we've got 9. Now, what if we went to encase that a bit further? Well, we'd probably start to get to, you can see what's building here, and this same pattern would extend here and here across here. So we would now build a bigger pattern. So I'm just following through. Can you see what happens here? And there'd be one more piece here. Now let's just think this through a little bit further. So originally the area was 1. We added 8 more on to that sort of idea. So we got to 9. Now what we're really doing here is adding, that's 4 long, that's 4 long, that's 4 long. So that's 4, 8, 12, 16. So we're adding another 16 long. All together, the total area would be 25. So now let's think about that set of numbers. We had 1, and then we had 9, and then we had 25. So 1 you might recognize as a square number, 9 is a square number, and 25 is a square number. And what we're really doing is adding these, every second square numbers being added on. Now there's a bundle more patterns that could develop from rods. That's just a very simple one. But just remember that built on the idea of area. So we wouldn't get into this pattern until we'd done some work with area. Likewise, when we did the fraction work, it relied on us understanding the lengths. So there's always a sequence in which some of this is taught. So we take the basic idea first and then build on it, build on it, and build on it. So in terms of lots of schools, I have lots of this material sitting around in their storerooms, the rods and so forth. There are a bunch of other materials that we could use for the same idea. But basically, as we have got a lot of this around, I thought, well, let's make the best use of what we've got. Now, if you don't have this material at home, you can cut strips that are 1 centimetre, 2 centimetre, and so forth. And as I said, there are other types of rods. The colour schemes won't be exactly the same, but the principles work exactly the same. So I hope that's been a little bit of an overview of how we can reason with rods. And you'll notice that we've always used a lot of language today, and we've moved the manipulatives as we've talked. Remember I said it's like the thinking is out there on the table. So thanks, Heather. I hope that was useful to you.
Paul, thank you very much. That was fantastic. Can I ask you to hold up the book, Reasoning with Rods, so everyone can have a look, just to let everyone know that Paul has actually written a book about this, and it's available on his website, it's Reasoning with Rods. So a lot of these games, principles and things that he's spoken about today, from the counting, sequencing, patterning, are actually in that book. Is that correct?
Yeah, and plus we've written a few what I call rod riddles, and so they're set up written in a sort of language, so children have to interpret the word question and build the model, and they like making their own riddles up as well. So I might send you a few to try.
That's fantastic, and we can definitely share some. Thank you very much for doing the webinar tonight. I really enjoyed it. The mathematical language is so important. I do find, even with my own children, that it's one thing that goes wrong, that one thing that sort of they need a lot of practice with. Thank you to Dr. Paul Swan's team, and also they'll be available on the first Monday of the month at Dr. Paul Swan YouTube channel and at EDX Education's YouTube channel. So thank you very much, Paul.
Thank you, Heather. Be safe.
You too.